Hi friends, I am Shravana and welcome back to Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Friends, in today's video, we will discuss about small files problem in Spark. Like in most of the cases, like whenever you are talking to someone, we can like often see this problem like there are small files issue in their cluster or something like that, right? So now let's understand what exactly is the problem and is there a way to resolve that. So for understanding the problem, first we will see what are the problems that we see because of these small file issues in Spark, and then we also talk about Hadoop, like how exactly the problem exists. Okay, I mean what is exactly the problem in the Hadoop cluster if we have smaller files, right? So before doing this, I wanted to show the demo for that. Now I have a small piece of code here. If you see, I for each like for I from 0 to 1000, I'm writing to one small file. So this is just to make sure that I'm generating a small folder with 1000 small files. Okay, if you see here, right? So I'm just creating the sequence and I'm just writing and I'm giving the schema here, id comma value, and I'm generating this. So now let me run this code. It's a very simple piece of code which will like for each number it will generate a small file. So I just have run it. It's loading. So meanwhile you can actually see this code and ask me questions in the comment section if you have any. Yeah, the job started here, and meanwhile we can check the UI as well. Yeah, Spark session is created just now. Now we can see some tasks. So here uh, like one task is created, one job is created, and we can see the number of tasks after going inside this. Okay, tasks are running. It will take some time because we have 1000 files generation, right? Still running. So we can see the completed jobs. I think the job is completed now. So total around 1000 tasks it would have taken. Because it's running in my local, I'm not able to open the local host after the completion of this. But what you can do is you can just add a wait here, and you can just check the number of tasks. So now let's see how many what files are getting generated here. We are writing to the small files test folder, right? So let's see that. So this is created. And if you can see here, there are 1000 part files are generated within this folder. You see this, right? So when I select as a whole, here, because I think 2 times I have run the job, because I the first time the page was like by the time I want to capture the 1,000 tasks, the localhost was closed, so I have run the job again. So we have this 2,000 files here, right? And in the UI also we can see almost 1,000 tasks are generated for that, like because we are having like 1,000 files we asked to create, right? So consider this as 1,000 for now. Okay, now, so you have seen, right, like when you see the UI, if you remember that part now, I cannot see that. So for each file there is a task created, which means that, you know, right, Spark is a parallel processing, like it does the parallel processing. So it processes the data in partitions, and each partition typically corresponds to a file or a part of file. You all know that, right? So now what happened, because of the small files, it has created individual task for reading each file. So we can see 1,000 tasks are getting spawned for 1,000 files. If there are 1 lakh small files, then Spark creates 1 lakh tasks. So because of this, it will be really difficult for the scheduling overhead. Okay, and also for because of this too many small tasks, frequent memory spills and garbage collection will happen. That is the main problem for this. Now let's try to read this. The same, right? Whatever we have generated just now, let's try to read this. Okay, this is small file test1, and I'm writing back to here. Okay, now let's see how many files it will write. I mean, of course it will write to 1,000 files, that you all agree, right? So what I will do is I'll okay, that's as part of the solution we will see this. So for now you understand, right? So when we are reading 1,000 files, it has created 1,000 tasks, which is actually, it's a overhead for the memory. Unnecessarily it is doing it. And if you take the similar thing in Hadoop, but this is my local machine, I have run this in the Spark standalone mode. You are running the similar kind of code in your cluster mode in, and where Hadoop is the like a cluster manager for you. Then imagine writing 1,000 files in different partitions in your Hadoop. So what is the problem there? You know, right? A name node has to like it has to take care of the metadata information of each and every block, right? So Hadoop, as the name node takes care of, tracks the metadata information. So how many are there? 1,000 different metadata information, 1,000 files related metadata information it has to store. It's actually not needed, right? So this is another problem. From Hadoop side, metadata overhead is another problem. So let's say there are 10 million small files. So just the metadata for storing that 10 million small files itself will become approximately 1.5 GB RAM in the name node, right? You understand the problem now, right? So that's why we always say that it's better not to generate smaller files. Hope you are clear with the problem now. Now we saw, right? So too many partitions, that we saw while running the job. High metadata lookup, as I mentioned, it has to, like, how many tasks are there and how many files are there, metadata to be updated with all the file place, I mean the path information. And because of this, too many spills will happen, and the shuffle also, it's kind of overhead for the Spark and even for the Hadoop. Okay, now how to solve this? So it is possible to solve this kind of issues. Okay, now how to solve this means, we have this code which we have generated just now. So now I mean, do you want me to run this again? Because anyway it will write it to 1,000 files, right? Now what we will do is, we will not write it right away. but we will say df1 equal to df.coalesce. So this coalesce, I think you have already seen my video about the repartition versus coalesce. So either of that we can use. Okay, it's based on your requirement. If you have 10 partitions and maybe 200 partitions by default one, and you have some smaller files and you wanted to reduce it to 100 partitions, you can use coalesce. Okay, but you have like maybe by default itself, let's say 30 partitions or something, and if you give coalesce 50 also, it will create only 32, because coalesce cannot merge the partitions. It will just distribute the tasks, and it will merge within the node, it will merge the partition. It within the node, please remember this, within the node it will merge the partitions, but it will not it will not invoke the shuffle operations between the nodes to mix the data, or to like merge the partitioned data. So if you have very fewer very large partitions, and then you wanted to merge it, either you can go for repartition and coalesce based on the number of partitions that you wanted to reduce. In this case we have almost 1000 partitions created, right, for us, because it's 1000 tasks. We have seen it. Now let's try to coalesce it to 50, and then after that we will try to write it to some other folder, and then we will print the get this num partitions. Okay, now let me run this code. See this I have. Okay, I have triggered the job. I'll just minimize these files here, this folder. Let's wait for the small files test3 folder. It's still building the workspace. I think some issue with the memory of my laptop. And while it is running, right, so as we were discussing about metadata, overwhelming metadata information in the name node, and also because the metadata is excessive metadata is present, right, so it will the lookup time increases in HDFS. And even the storage space, right, for example, as you know, HDFS block size is 128 MB by default. Let's say you have files for 10 MB, each file is 10 MB, then every block will have one file. Let's say unnecessarily the remaining 118 MB of the memory will be wasted in each block, correct? So that is also another issue, and because of that the storage inefficiency will be there. Okay, that is the problem that we are facing using because of this small problem. So now it's completed here. This job is completed. It's saying path does not exist. Let me check it. I think expansion also will taking some time because of the number of files here. Small files underscore test underscore 1 here. Okay, that is the issue. I've re-triggered the job. Okay, meanwhile let's see the other options. So usage of coalesce, now we are running the coalesce, right, we are using the coalesce, and we will see what exactly happens when using of coalesce. And coming to the second point, we can also configure Hadoop for the efficient storage. So here we can mention the block size, and we can set up the, and in Spark we can set up this configuration for max partition bytes to 256. Okay, this is not 265. 1 second. Okay, 256 MB. So these two things, in for the first one you can set it up in Hadoop, and second one for the Spark you can set this up and then you can try it out. Okay, and third one is if we are using the data lake, then there is an option called auto compaction that you can set that to true, so that automatically this compaction will be taken care in data lake. And For example, if we are writing some large files and all, then what we can do is we can use the repartition option. Before even writing, we can just use this repartition of 10 and then we can write to whatever path you want. Okay, so these are the things that we can do, but this is kind of trial and error. Like how many repartitions we have to do, there is a actually there is some approximate usage of formula also there. Please check my video on repartition and coalesce. You get more details about how to do the repartition. We can actually give the column name as well along with the number of partitions. So please go through that and then you can set it up, these things. This job is still running. Let's see the UI. So earlier you see, right, 1000 or something was there, but now only 50 tasks are spawned, and like you can clearly see the task details here, right, task number. So only 50 tasks are spawned here. So what will happen is, because of that, the files will be merged while writing to that 50 partitions. From 1000 partitions to 50 partitions we have reduced, which means that even the memory, so earlier for each file one block of HDFS we have used, which means that only 10 MB or even lesser, because it doesn't have anything, right, apart from ID and value. So it consumed very less space in each block. But now as we are merging the files and then we are storing it only in 50 partitions, so let's see how much it will be taken. So here we can see here the like number of tasks. I think the job is completed now. Okay, so if you can see here, number of partitions, I just printed using this get partitions and it is saying that it's 50. Now refresh here and see how many files are generated. Here the small files test3 folder is generated, and here you can see 50 items selected, means 50 files. How many files we have fed into the machine? 1000. All these 1000 files are merged into, like it got, the sizes got adjusted. If you if like maybe 20 files together like that, it got merged, and in a single file we can see more rows now. Okay, this way we can use this coalesce method to help the memory related everything whatever we just discussed. So this is like coalesce is one of the ways, as discussed. Repartition is another way, and then we can set up the max partition bytes to 128 MB or 256 MB based on whatever is the file size that you are having. And for HDFS we can use this combined file input format, and also in the data lake we can enable auto optimize or auto compaction. So these things we have seen, right? So this way we can reduce the small files within a partition. So how it helps, as we mentioned, it will help us in the memory consumption and metadata information, and also faster processing, and most probably the quicker completion of the Spark job. Okay. Hope this is useful to you, friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.